Which of the following are APs? If they form an AP, find the common difference and write the three more terms. So basically, we have to check if the sequence is an AP. This is in sequence following a particular rule. Is that rule applicable? I mean, is it same as the definition of an AP? Is what we have to check. So how do you check that? How do you check if something is an AP? Well, it's simple. First is write the heading. I mean, that's supposed to be a bad joke. Anyways, A2 minus A1. You have to find that, right? That's 2. Why is that I'm doing this? The basic idea of AP is that the difference between any consecutive term has to be same. Then A3 minus A2, which is equal to 8 minus 4, which is equal to 4. And since the difference is not the same, right, you will conclude that as A2 minus A1 is not same as A3 minus A2, right? This implies the sequence is not an AP. Okay, guys, quite simple. So similarly, oh yeah, I'll check with the Python code. So I have a code over here, right, which helps us in doing whatever they asked. So here I have to enter the elements of the sequence one at a time. Type n to exit the loop. So I'll show you what I mean. So we have to type in 2, 4, 8, and 16. 2, 4, 8, and 16. So since I have only the first 4 numbers that is given, I just have to type end and it will tell the answer. The sequence is not an AP. Well, that's the answer, right? So if it's an AP, let's see what it will do. First thing is let's get a sequence that is in AP. So pause the video and write if this particular thing is an AP. And if so, find three more elements. So please do pause because all this is basic and quite important. Again, whatever is basic by default is important, and on that concepts are built and the questions are asked. Okay, for ease of doing, I'll write this as 2.5 and this is 3 and this is 3.5. Next is we have to check. So we can check all of this by taking any two consecutive terms. I'll go with A3 minus A2. 3 minus 2.5. Clearly this is 0.5. And A4 minus A3, 3.5 minus 3, which is nothing but 0.5 again. And we can conclude as A2, A3 minus A2 is same as A4 minus A3. This implies the sequence is an AP. Okay, well and good. So next thing is we have to find D. D here is obviously 0.5 and then the sequence. So the sequence is 2, 2.5, 3, 3.5, 4, 4.5, and 5. These are your next three terms, right? So let's check. Let's see if our code can do the same. So we have 2, 2.5, 3, 3.5. This is all that is given. So I'll type in end. And yes, the sequence is an AP. The difference D is 0.5. That's what we got. And we have the first around 100 elements. Okay. So 2, 2.5, 3, 3.5, 4, 4.5, 5, 5.5, and the sequence goes on. So let's try two more questions before we end this video. Which of the following are AP? If they form an AP, find the common difference D and write three more terms. So we have given. So here the given is minus 1.2, minus 3.2, minus 5.2, and minus 7.2. Next, the check. So A3 minus A2. A3 is this, A2 is that, minus 5.2 minus of minus 3.2. So the difference here is clearly 2. If you want to see the math, minus of minus is plus 3.2. The difference, it has to be a difference. Why? One is negative, another is positive, and the difference is 2. But since the negative term is big, so you have 2.0. Next is A2 minus A1. So we have minus 3.2 minus of minus 1.2. So this 2, I'll show the math, plus 1.2. So the difference is negative, and we have 2.0. And thus we can conclude as A3 minus A2 is same as A2 minus A1. This implies the sequence is an AP, where D is equal to minus 2, and the sequence itself is minus 1.2, minus 3.2, minus 5.2, minus 7.2, minus 9.2, minus 11.2, and minus 13.2. So let's verify if we are right, or let's check our code if it's working properly with decimals and negative numbers. I think this is the first time we're getting negative numbers, right? So the numbers are negative 1.2. Let me be sure. Yeah. Negative 3.2, negative 5.2, negative 7.2. And I'll end my input. So we have the sequence is NAP, the difference is minus 2. It works. And we have the first 100 terms. So we have till minus 17, okay, 13.2. We have written till there. Now we have given minus 10, minus 6, minus 2, and 2. So let's check if it's an AP or not. The check. So A3 minus A2 is minus 2 minus of minus 6. Minus 2 plus 6. So this is 4. And A4 minus A3. So we have A4 is 2. A3 is minus of minus 2. So this is plus 2. So this is again 4. Right? Then we can conclude as A3 minus A2 is same as A4 minus A3. This implies the sequence is an AP. Therefore, D is equal to 4, and the sequence is minus 10, minus 6, minus 2, 2, 6, 10, and 14. Right? So let's verify this. So we have minus 10, minus 6, minus 2, and 2. minus 10, minus 6, minus 2, and 2. Let's end it. And we have the sequence is an AP, the difference is 4, and we have the first 100 terms. So this is our answer.